All right, hello and welcome. In this video, we're going to look at how to calculate total parallel inductance. So when we look at this circuit here, we can see from the top, this entire node range up here all attaches to the same spot, no resistances, and that implies a parallel connection. And so as we follow each of these nodes, we'll see that this parallel branch comes down through L1 and leads us directly to our ground. So we'll say that L1 is in parallel with, we'll do the next branch over. We'll continue on and see that there is another branch here that leads down through L2, and that connects at the bottom to our ground location also. So that's L1 is in parallel with L2. And you see there's yet another branch here that leads down through L3, and that connects down to the bottom ground also. So that is L1 in parallel with L2 and parallel with L3. So we can plug that into our total parallel equation for our inductors, and that would give us our LT, our total inductance for the circuit. So first thing I would do is watch out for all of your micro versus millihenries here. We need to make sure that they're all kind of in the same value range for that. And this is the -6 location for both of those. And this is the -3 location. So we want to make sure that all those match. We know in parallel, we might end up with a little bit smaller number, right? Our output for this total parallel equation here should be less than the smallest inductor that we have. So we might move it down to micro on our millihenry one over here. So from our -3 location, move that back 1, 2, 3 spots to our -6 location. So we can say that's 1,000 micro henries, and we'll use that in our equation. Put that in our Desmos over here. Put into our 1 over 1 over equation for our parallel. So 1 over 1 over. Our first inductor is 1,000. We'll say plus 1 over our second inductor, 450, plus 1 over our third inductor, 1,100. So now our total parallel inductance, LT here, is equal to 242 micro henries. All right, let us know if you have any questions.